We are to find the odd integers from 1 to 100. This is an example of finite sequence. In illustration, the odd numbers from 1 to 100 will be 1, 3, 5, 7, until 99. Let us identify. The last term here is 99. This will be our a sub n. Let us identify the other given. Our a sub 1 here is 1. Our a sub n here is 99. The common difference between the terms will be 2. And our n here is unknown. How many terms are there from 1 to 99 that are odd numbers? So n here is unknown. So if we will use this formula for our arithmetic series, we need first to solve for n. By doing so, we will go back to our general formula. That is, a sub n is equals to a sub 1 plus the quantity of n minus 1 times d. So we are to solve for n. So let's substitute. Our a sub n here is 99. Our a sub 1 here is 1. Our d here is 2. Now let's solve. Copy 99, copy 1. 2 times n will give us 2n. 2 times 1 will give us negative 2. Continue. So we will have, again, copy 99. Then we will have combined like terms. This will give us 1 minus 2 from here. 1 minus 2 plus 2n. Continue. 1 minus 2 will give us negative 1. So this will be 99 is equal to negative 1 plus 2n. Transpose or by APE, 99 plus 1 is equals to 2n. 99 plus 1 will give us 100 equals to 2n. Divide both sides by 2 so that we can solve for n. 100 divided by 2 is 50. 2n divided by 2 is n. So n here will be 50. Since we already solved for n, we can now proceed to the arithmetic series. Again, a sub 1 is 1. A sub n is 99. Our n here is 50. Common difference is 2. This is the formula when a sub 1 and a sub n are given. A sub n is equals to n over 2 times the quantity of a sub 1 plus a sub n. Now let us substitute the given s 50. So what will be the sum of all these 50 terms? Our n here is 50 over 2. A sub 1 is 1. A sub n is 99. Solving for the 50 terms, this will give us 50 divided by 2 will give us 25. This will give us 100. Continue. So we will have 2,500. The sum of the 50 terms will be 2,500. Find the sum of the multiples of 3 from 15 to 45. This is an example of a finite sequence. In illustration, we will have 15, 18, 21, until 45. Let us identify the given. Our first term, or a sub 1 here, is 15. Our a sub n here, the last term, is 45. Our n here is unknown. The difference between terms is 3. Now let's solve first for n. Let us substitute. Our a sub n is 45. Our a sub 1 is 15. plus quantity of n minus 1. The d here is 3. Now, let's continue. Copy. 3 times n will give us 3n. 3 times negative 1 will give us negative 3. Now, let us simplify. Combine like terms. We will have 15 minus 3 plus 3n. Continue. This will give us 12 plus 3n. By APE, or if we will transpose 12 on the other side of the equation, this will be 45 minus 12 is equal to 3n. This will give us 33 equals to 3n. Divide both sides of the equation by 3 so that we can solve for n. This will give us 11 is equal to n. There are 11 terms from 15 to 45 in multiples of 3. Let us now continue with the arithmetic series. Again, we have 15, 18, 21 until 45. The given will be a sub 1 is 15, a sub n is 45, Rn, or there are 11 terms. Again, if the sequence is a finite, we will use this formula, or if a sub n is already given. So, let's continue. Let us substitute now. Rn here is 45. Sorry, Rn here is 11. Our first term, or a sub 1, is 15. Then we have here, our a sub n is 45. So we can write it as 11 times the quantity of 15 plus 45 will give us 60. All over 2. So we have 66 here. $660. 11 times 60 is 660 over 2. 660 divided by 2 will give us 330. So the sum of the sum of our arithmetic series from 15